Hi, we're going to work on lesson 1.3 about slope and rate of change. You talked a little bit about slope and rate of change, and you talked a lot about it in Algebra 1. You talked a little bit about it in geometry, and now we'll pick up and use it quite a bit here in Algebra 2. So this is the 1.3 lesson. First thing is a little 5-minute check here. How do you tell if something is linear? Remember, need to be able to write it in either standard form or in y equals mx plus b form. This has a squared, so it's a big fat no, right? Is this linear? I believe it is. It's in the form of ax plus by equals c right now. You could also solve and put it into y equals mx plus b form. So this is a yes. This one, if I was going to negative y equals 10x minus 2, divide everything by a negative, I can put it into y equals mx plus b form. I could also get it into standard form by adding the y over, and then I can just flip-flop because of equality, and boom, I'm in ax plus by equals c. So this is yes. Fractions, are we scared of fractions? We're not. Standard, oh, they wanted this in standard form, so I guess I solved that right here. Here's standard form. Remember, standard form, a, b, c, a has to be positive, and we're not allowed to have fractions. So I see this one right here. The first thing I'm going to do is multiply everything by 3 and get 6y equals x minus 21, right? And then I'm going to, I would probably, I don't know, move the x over here. Negative x plus 6y is negative 21. Multiply everything by a negative 1 to change those signs. X minus 6y equals 21. And there you have it. The initial fee at a gym is $200. It costs $55 per month to have a membership. Write a function for the total cost. C of x of having a membership for x months. What is the cost of having a membership for 18 months? So I would say the cost in x months is equal to $55 every month plus $200 flat fee one time. The cost for 18 months tells me to substitute in 18. I'm going to need my calculator and do 55 times 18, which is $990, but then add on the $200, and I get the cost for 18 months is $1,190. Make sure you're going to the gym every day. New vocabulary, rate of change. You've been dealing with rate of change for a long time. Miles per hour, meters per second. We're talking about slope. What other words are used to in place of these? It's in y equals mx plus b, the m is the slope, right? We've talked about that before. Got rise over run. You got change in x over change in y. You've got, in terms of words, it's pitch or how steep something is. And then you have your slope and other different types of rates of change as well. College admissions. College is expensive. 2016. So these are kind of like ordered pairs, right? You got a year and then you have a cost. You have a year and then you have a cost. And over here you have a year and then you have a cost. Find the rate of change between 2014 to 2016. Well, it's really change in y over change in x. Remember, the Greek symbol delta means change in. So we're going to do 31,388. So we see how much different it is. So we're subtracting, right? Because we want to know students per year. So you kind of know, like, how do you know which one to put on the top of the fraction and which one to put on the bottom of the fraction? Well, you're subtracting 31,388 388 minus 25,949. I get 5,439 divided by 2, right? So my calculator does most of that work for me, and I get my rate of change is 2,719 and a half, and that's going to be, again, we have to label students per year. That was the rate of change. So we are going up. We are increasing. It's a positive number. If it was a negative number, then we'd be decreasing. Okay? So rate of change. Find the rate of change on the table. So you can look at a table. You do need to make sure that it's consistent. So I went up 2, and then I went up 4, and then I went up 4, and then I went up 2. And that's fine. But we do want to, we got distance, we got time. So we're going to do distance over time, which means this is going to be a feet per minute. So maybe this is a turtle crossing the road. How many feet do they cover per minute? Well, as long as our rate of change is consistent, we can go anywhere. Change in y, or distance over change in x. I'm going to do 16 minus 8 over 4 minus 2. I get 8 over 2. I get 4 feet per minute. We're moving 4 feet per minute. So this one went up 16 feet in 4 minutes. Is that 16 divided by 4? Is that feet per minute? Look at here. 56 minus 8 is 48. 48 divided by 12. Is that 4? Yes, it's consistent. 4 feet per minute is the rate of change. Make sure you're labeling. This is not 100% linear, right? And that's okay. Sometimes we make linear predictions, but even though the data is not 100% linear, we can still do that. Find the rate of change. This is going to be the average rate of change from here to here. So it's really, what we're talking about here is, this is going to be stores per year, right? So we went and notice it's in thousands. So really, when we do our change in y over change in x, now you can really see it because it's stores. So this is going to be stores per year. So now we're going to do 34 minus 7 over 2006 minus 2001, which this is going to be what, 27 over 5. And what is 27 divided by 5? I think it's 5.4. Now again, these are averages, rate of change. So 5.4 stores per year. Do you really change a 0.4 of a store? No, but again, we're talking about if we're going to make predictions in the long run, these are the data that we use. Now this is more slow. It is a little bit exponential there, or it might be logistic probably, but you can connect it with a straight line, and you're still making your rate of change. Again, label everything. Label everything. Refer to the graph. Find the average rate of change of the percent of households with computers in the United States from 2000 to 2004. Believe it or not, there was a time in our life, my life, where not everybody had a computer. So if we're doing, we're going to do percent per year. So again, what's the change in percent? Well, 61 to 74. That's 13%. Can we do that? Oh, back here, that this is 5,400 stores, right? Because it was in thousands. So 5.4, I should probably make note of that. Almost made my first mistake of the year. Good recovery though. So I could change that to 5,400 stores per year. Yeah, gotta watch out. Gotta watch out when they do that stuff over there too. You can't have that. So this is 13%, and then it's over 4 years. So again, we're subtracting in this direction, and then we're subtracting this direction, right? And to see how long we're going here. Wait a second here. This is going the other direction. Find the average rate of change of the percent of households with computer. Oh no, they just changed this the other direction. 13 divided by 4. 13 divided by 4. We're talking about 3.25% per year. And these are written a little bit backwards. Usually are years, but they did tell us percent of households up there. Slope of a line, again, we're talking about the M is the slope of the line, and it's change in y over change in x, which is this guy right here. y2 minus y1 over x2 minus x1. It's exactly what we just did on all of those example problems. We subtracted the y values, and then we subtracted the x values, and we divided. So it is very simple for you to say m equals m is slope. I like to always start, it doesn't matter which way you go as long as you're consistent. Negative 2 minus 4 over 1 minus negative 1. So this is negative 6 over positive 2, which is negative 3. It wouldn't have mattered if you went 4 minus negative 2 over negative 1 minus 1. Because look at, you get positive 6 over negative 2, which is negative 3. Coincidence? I think not. So the slope there is negative 3. Find the slope of the line that passes through. Again, I like to go second one minus first one, second one minus first one, 10, negative 7. And I leave all my slopes as fractions, simplified fractions. Because when you go to the graph, the rise over the run, that's easier to use. Very simple. Rise over run. Up 1, right 2. Rise over run. Rise is up, down. Run is right, left. Up and right are positive. Down and left are negative. Up 1, right 2, boom, it's a half. You should be able to follow that pattern. Up 1, right 2. What if we went down 1, left 2? Well, that's negative 1 over negative 2. Still works out. Find the slope of the line. Down 2. Again, change in y. Down 2. 1, 2, 3, 4, 5. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right 9. Negative 2 ninths. Rise over run. What if I went the other way? Up to left 9. Up to, oh my gosh, I get the same thing because negative 2 over 9 is the same as 2 over negative 9. Isn't that great? That is just great. Find the value r. So now you're given m. So I like to do 5 over 3 equals y2 minus y1 over x2 minus x1. 5 over 3 equals r minus 8 over 6. And now you've got a bunch of different options. You can cross multiply. You can think about that if this is 5 over 3, it has to be 10 over 6. You got things to do. Let's just cross multiply. 3 times r minus 8 equals 30. If I was doing equals, remember how to cross multiply? Divide by 3, divide by 3. R minus 8 equals 10. Add 8, r equals 18. 18. Check your work, right? Check your work. 18 minus 8 is 10. 11 minus 5 is 6. Is 10 over 6 5 over 3? It is. It is. Let's change color. I've had too much of that. Down here, again, negative 1/3. You can assign the negative to whatever you want, either the top or the bottom. It can't be both. And then I would do negative 2 minus r over 4 minus negative 2. And I get negative 1 over 3 equals negative 2 minus r over 6. And I would cross multiply. Cross multiply. 3 times negative 2 minus r equals negative 6. Negative 6 minus 3r is negative 6. Negative 3r equals 0. Holy cow, add 6, add 6. R is 0. Well, that was anticlimactic. Negative 2, 0. Does that work? Negative 2, 0. And we can do negative 2 divided by 6. Yep, it works out. R is equal to 0. So we're just using the formula, solving with algebra. There we go. That's what we got for 1.2. That's what we got for 1.2. Get to it.